that says limit. Okay, limit as x approaches 1. Let's take x to the 4th power minus 1 or device. Let's take 2x squared. Let's take minus x minus 1. Let's limit this problem. Okay, so in limiting a function in this form, what do we do? We say, here comes the question. First of all, you check this limit whether it does exist or it does not exist. All right, so how do we check this? We check this by plugging in a value of x. We say as x approaches 1, so that means we're going to plug in 1 wherever we see x's. We're going to plug in 1. We see x here, so the x's here are many. So here we're going to plug in 1. Let's proceed as we say it. All right, so that means here we're going to say limit as x approaches 1. Where's x? X is x to the 4th power. That means 1 to the 4th power minus 1 or divides 2. What's x there? X is there. S squared. All right, minus 1 minus this 1. All right, we check the limit whether it really does exist. If it does not exist, we have to make it to exist. Okay, so let's proceed with this problem. Okay, so right here we're going to say 1 to the 4th power. That means 1 times 1 times 1 times 1. What's going to give you? It's going to give you 1. Yes, 1 minus this 1. All right, is equal to. All right, so 2. We have 1 square. This 2, this square is affecting the 1 that's inside here. All right, so 2, 1 to the power of 2. That means 1 times 1. You multiply 1 by itself 2 different times. All right, so here we're going to say 2 times 1. Yes, minus 1 minus 1. All right, so that means we have 2 minus, okay, negative 1, negative 1. Negative 1 and negative 1 gives you negative 2. Why? Because when 2 like sign appears, you add the number and take one of the signs. All right, when 2 like sign appears in adding a number, you add and take one of the signs. All right, so here we're going to have minus 2. Okay, that means negative 2 minus 2 gives us 0. 1 minus 1 gives us 0. So we're going to have 0 over 0, which is 0. All right, so the limit in technique this way does not exist. What do we do to make this limit exist? Yes, what do we do? Okay, so let's get to this real problem. Let's get to this real problem and simplify it to make this limit exist. All right, so what do we do here? Okay, we do like this. What do we do here to make this limit to exist? Proceed. Focus. All right, so here we're going to factor out the numerator. All right, then we factor out the denominator. Yes, we want to make way that this limit really does exist. All right, so we're going to do it like this. Okay, limit x approaches 1. Okay, so the factor of this, to factor out this, we say x squared minus s squared minus s squared. Okay, 1 plus. Okay, we have factored out this term, this first term, this one that's up here, we have factored it out. All right, so that means s squared plus 1 times s squared minus 1 give us s to the full power minus 1. All right, now let's proceed. Let's factor out the denominator. If factor out the denominator, we say it's going to be equal to, okay, 2, what do we do here? 2x. 2x plus 1. 2x plus 1. We have 1 here. 2x plus 1 multiplies x minus 1. It closes. All right? So this is how we factor out this. Okay. 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 Now, We factored out this. What do we do next? Can we cancel any term up and down? Is there a term in the numerator that is equal to the term in the denominator? No. So what do we do again? We have to factor out this term again so that we can have the same term up here and have the same term down here. Alright, so let's proceed. This is equal to x squared plus 1. So let's factor out this term. This is going to be x plus 1, x minus 1. Alright, we have x plus 1, x minus 1. Divides this divides, alright, 2x plus 1. Alright, 2x plus 1. Then we have this x minus 1. Alright, so we have had this now. What do we do? Now here, this x minus 1 cancel this x minus 1 because they are the same. Okay? Now, here we are now left with x squared plus 1 multiplies x plus 1. 2x or divides 2x plus 1. So, in this problem, what do we do here? Now, we're going to multiply this by this. The x squared plus 1 times x plus 1. So, let's multiply and then plug in the limit value. Alright? So, here is going to be equal to x squared times x gives us s cubed. Alright? Gives us s cubed. X times 1 gives us plus s squared. Alright, s squared times 1 gives us s squared. Then we come to the next term. X times 1. 1 times x gives us x plus x. Alright, now 1 times 1 gives us plus 1. We want to prove that this, we want to show that whether this limit exists. Now here we check the value here, it does not exist. Now let's come here. Do you see how simple it is? Do you see how easy it is? Now, to limit this, alright, we have 2x plus 1. Alright, so we said now it's going to be equal to. What do we do here now? We have factored this out, we have multiplied it. So, right now, what we have to do is to plug in the limit value. That means, anywhere we see x, we put 1. Anywhere we see x, we put 1. Because the limit says as x approaches 1. So anywhere we're going to see x, we're going to put 1. Let's do it as it has been said. Alright? So here, limit as x approaches 1. Let's proceed. Limit as x approaches 1. Limit this. So that means wherever we see x, we put 1. So here, we're going to have 1 cubed plus limit as x approaches 1, x. So we're going to put x squared and 1 squared plus 1 plus 1. Okay. All divides. All divides right now is going to be equal to 2. All divides 2. X value 1 plus 1. Alright. So here now is going to be equal to. Alright. 1 cube, that means 1 raised to the 10th power, 1 times 1, multiply 1 by itself 3 different times, it's going to be 1. Alright? So here, if we multiply it by itself 2 times, it's going to be 1. Alright? So that means 1 plus 1 plus 1 plus 1.
Plus 1 plus 1 plus 1. All divides 2 plus 1, which the limit will be equal to 4 all divides 3. Guess what? We are done, and that's the answer. So thank you very much for following us.